SCADA is a control system architecture, comprising computers, network data communications, and graphical user interfaces for high-level supervision of machines and processes. SCADA basic functions are data acquisition, logging, archiving and retrieving, supervisory control, trend and alarm generation, information storage and reports, analyze and calculation of complex process. Before discussing about the architecture of SCADA and different types of SCADA systems, first we must know a few SCADA basic components, which are human-machine interface, PLCs, remote terminal units, supervisory system, communication infrastructure. Human-machine interface. HMI is an interface between machine and human or operator. Operator can see what is going on in the field. He can see the process data, trending and diagnostic data of any sensor or machine, and also could control the process. PLC. PLCs are used to control the process, take input from sensors, execute program, and then take action according to saved instructions. Remote terminal units. Physical objects in the SCADA systems are interfaced with the remote terminal units. These units are used to transmit telemetry data to the supervisory system and receive the messages from the master system for controlling the connected objects. Supervisory system. Supervisory systems allow information from production processes or physical installations to be monitored and tracked. Such information is collected via data acquisition devices, which handles them, analyzes them, store them, and finally present them to the user. Communication infrastructure. Communication between devices is a backbone of SCADA. Generally, the combination of radio and direct wired connections is used for SCADA systems. In hardwire, different high-speed medias are used for communication. SCADA systems have evolved through 4 generations as follows. First generation. Monolithic or early SCADA systems. Second generation. Distributed SCADA systems. Third generation, network SCADA systems. Fourth generation. Web-based SCADA systems. Monolithic or early SCADA systems. In this generation, common network services were not available. These are independent systems without having any connectivity to other systems. All the remote terminal unit sites would connect to a backup mainframe system for achieving the redundancy. In the second generation, the sharing of control functions was done by using local area network, LAN. The cost and size of the station were reduced compared to the first generation system, as each system of the second generation was responsible for performing a particular task. In this generation, network protocols were not standardized. The security of the SCADA installation was determined by a very few people beyond the developers, and also the protocols were proprietary. This third generation was networked and communicate using wide area network, WAN, systems over data lines or phone. These systems use Ethernet or fiber optic connections for transmitting data between the nodes. This generation used PLC for monitoring and adjusting the routine flagging. It was also able to connect to the third-party peripherals. In fourth generation, infrastructural cost decrease by adopting IoT with cloud computing. Integration and maintenance is also made very easy. Different SCADA vendors are available in market. Some of them are ETAP ADMS, by ETAP, Litmus Etch, by Litmus, Open Automation Software, by Open Automation Software, Ignition, by Inductive Automation, InView IoT Platform, by Init Technologies, Somatic SCADA by Siemens, Genesis 64 by Iconics, Action.net by Spin Ingenieria, DAQ Factory by Aziotech, EIS Bear SCADA by Alexander Mayer, Factory Studio by Tatsoft, Schneider, VZR SCADA by Martz Technologies. Honeywell. GE Grid Solutions. Integra XOR. By Ecava. And etc. SCADA finds uses in a wide range of applications. For example, oil and gas, chemical production, environment control, food and beverage, manufacturing plant systems, water and wastewater management, mass transit systems, traffic signals, agriculture/irrigation, pharmaceutical, telecommunications, electric generation, transmission and distribution systems, and many others. So guys, SCADA systems offer numerous benefits and advantages when used in industrial applications. It offers, automate industrial processes, real-time process data, reduce downtime, record and log events, directly interact with field devices, increased life of the equipment, reduced labor costs required for troubleshooting or service, increased compliance with regulatory agencies through automated report generating, no requirement of large capital investment, monitor from a remote location 24/7. For more informative videos, subscribe my channel. Thanks for watching.